Hello, hello, and welcome to the next lesson. We are in a brand new chapter now, chapter 3, on parallel and perpendicular lines. This first lesson is going to focus all on lines and angles. And our standard is G.6.4. Students prove and use theorems involving the properties of parallel lines, cut by a transversal, similarity, congruence, triangles, quadrilaterals, and circles, all of that. So let's get started. This lesson is an introductory lesson with a lot of vocabulary words. So here are the first 3 for you. Parallel lines. Now, I know that you are familiar with parallel lines. You've heard that before. We know lines that do not cross, do not intersect. But here at the high school level of geometry, you need to add in the term coplanar. So we know parallel lines also have to be in the same plane. If they're not in the same plane, they cannot be parallel. It doesn't matter if they intersect or not. So make sure you have that requirement added to your new knowledge. Parallel lines are coplanar in the same plane, and they do not intersect. Okay, moving along, skew lines. That's a new term. These lines are not coplanar. They are not parallel, and they do not intersect. So there's a lot of nots going on here. Not in the same plane, not parallel, and do not intersect. I'm going to show you that in just a moment. Lastly, parallel planes. Just like parallel lines, but the entire plane now does not intersect. So let's take a look here. We have a cube over here, 3D box. Let's get some labels going on it to kind of explain all of these terms we just reviewed. So let's label some points here. Let's have A, B, C, D, and you're going to want to add these notes to your document as well with all of the points and everything that we do here. E, F, G, H. Now, did we have all of the points? Did we miss any? Because we want to make sure every place is labeled. Okay, so I think we have all of the corners labeled with a letter. Those are the points. And then I just want to do some kind of shading as well, just to kind of highlight some of the planes and a little bit easier for us to talk about. This top plane in kind of orangey yellow, and the bottom plane too. Okay, so let's talk about parallel lines. In order for lines to be parallel, they have to be in the same plane. Okay, so let's take a look at this bottom plane that was just shaded. What lines are parallel just in that plane? Well, we can use AD. Would be parallel to HE. Okay, because they're in the same plane and they're not ever going to cross. So you can add that here and say AD is parallel to HE. Those two vertical bars are the shortcut abbreviation for parallel lines. Okay, so that's one option. But AD actually is in 2 different planes. You have the flat bottom of the box, but AD is also in this left side of the box too. We can highlight that in green. So this whole side of the box as well, you can see. So then AD would also be parallel to BC. Okay. And you can add that to your notes as well. Just another example, AD parallel to BC. So hopefully that makes better sense to you about parallel lines. They have to be in the same plane and not intersect. So There might be some other lines here that don't cross, but that doesn't matter. If they're not in the same plane, they do not count as parallel lines. Okay? So let's take a look at skew. Skew lines are not in the same plane, but not parallel and do not intersect. So let's keep going with AD because that's where we started. Can we identify some lines that are skew to AD? So they cannot be in the green plane or the bottom orange plane, right? Cannot be parallel, cannot intersect. So some good examples of skew would be, look at GH going down here. That's never, ever going to cross AD. It's all the way back there. It's not in the same plane. It's not parallel, and it's not going to cross. So AD and GH, never going to cross. Okay. Another example of something that's not going to cross AD could be FE. Okay. Not in the same plane, not parallel, and never going to cross. So you can add that here as examples as well. AD and GH. And AD and FE. And we do want to make sure we are mathematically accurate and precise. So these are lines. We should put the arrows on it. And then same thing for up here. We should be precise, highly skilled mathematicians, and make sure we write things the correct way. Okay, parallel planes. Parallel planes, we talked about planes that do not intersect, and we have already kind of color-coded that. The yellow plane on top and the yellow plane on the bottom are parallel. They're never going to cross. And if you physically had a box in front of you, you could visually see, hey, the top and bottom are never going to intersect. The left and right are never going to intersect. The front and back, okay? So let's write those answers down here for parallel planes. Let's take the bottom plane, which is A, D, E, H, is parallel to the top plane, which is B, C, F, and G. Okay? So those are your first three vocabulary words of the lesson. We're going to move on and talk about transversals and the angles they create. The first term here is transversal. That is a line that intersects another set of lines, which is usually two or more. And this transversal is going to create several new angle pairs. So let's look at an example of transversal. You do need to draw this as well. So that's a line and this is a line. So that creates a set of lines. And then a line that intersects them both is the transversal. So this longer diagonal line is the transversal. Okay. Every time you have a transversal intersecting another set of lines, it creates these different areas, okay? The area between the set of lines is known as the interior. Let's see, you can write that kind of neatly here. Or it's abbreviated at least. INT for interior, okay? That's between the two lines. Okay. Then the area outside of the two lines is going to be called or referred to as the exterior. Okay, and so that's all of this and all of this. So recap, you have two lines. A line that intersects both of them is the transversal. Whenever you have that phenomenon, it creates an interior between the two lines and exterior outside of the two lines, okay? Now let's talk about the different angles that are formed. Alternate interior angles. These are two angles that are on the interior, but in opposite sides diagonally of the transversal. Copy that down. We will go over some examples of that in just a moment. Two angles that are on the interior, so in the red section, but in opposite sides diagonally of the transversal. Then alternate exterior angles, kind of similar. These are two angles that are on the exterior, but also opposite each other diagonally of the transversal. Next up, we have same side interior angles. This is a pair of angles, two angles that are on the same side of the transversal, like as in left side, right side, top side, bottom side. I'll show you that in a moment. But they're on the interior, okay? Same side of the transversal, but in the interior. And they're also known as consecutive interior angles. So you'll hear either way, same side interior or consecutive interior is talking about the same thing. Lastly, corresponding angles. Two angles that have corresponding position, same position. They're in the same place. With respect to the transversal, they're just in a different intersection, okay? I'm going to make all of this make sense in just a second. So make sure you have all of these definitions for these new terms in your notes. You might need to pause it. Okay, so let's go over these new four pair of angles, four pairs we have. We need to number the angles. So you can see there's an angle created here, one here, one there, another angle here, this one here, and here, and here, and here. And guys, anytime you have a transversal intersecting two lines, which is what we have here, it creates 8 angles. Okay, it always creates 8 angles if it is intersecting two lines. So here we have the 8 angles, and we're going to use these numbers to help us visualize and determine, each set of these pairs we have here. All right, so alternate interior angles are first. It does say interior, right? So we're only going to be looking in the interior of the two lines. So I already have that in red. In between the two lines is the interior, okay? It says they are opposite each other, diagonally across the transversal. Let's highlight this transversal and make it stick out. This is the transversal in yellow. Okay. And for alternate interior angles, I'm only going to be looking at the angles 3, 4, 5, and 6 because those 4 are the only ones in the interior. So to be alternate, they have to be diagonal from each other in opposite side of the transversal in opposite position. That means if I take angle 3, it can only be alternate with 6 because one is top left side of the transversal, the other one is bottom right side of the transversal, okay? 3 and 4 are not considered to be alternate. They're right beside each other. They're touching. So to be alternate, you have to be diagonal. One is at the top, one is at the bottom, and they're on opposite sides of the transversal. So for examples of alternate interior, you can say angle 3 and angle 6. But you can also say 4 is alternate interior with 5 because they're opposite diagonally, okay? All right, let's move on to alternate exterior angles now. Now we're focusing on the exterior part, which is everything like all out here and all out here, okay? Outside of the red spaces. So those are angles 1, 2, 7, and 8. Those are considered exterior angles. But we don't just want exterior, we want alternate. And this is the same thing. What's diagonal and opposite position? So if we use angle 1, it's in the exterior. Which one is alternate? That would be 8. Okay, because they have to be on two different sides of the transversal and in opposite position. 2 doesn't work, they're side by side. 1 and 7 can't work because they're on the same side of the transversal. So alternate exterior angles would be 1 and 8. And also 2 and 7. Okay. All right, let's take a look. Same side interior angles. I might have to clear up some of my picture here. But this is referring to just interior. So we're only going to be looking in the red area with angles 3, 4, 5, and 6. 3, 4, 5, and 6. So for same side interior, they have to be on the same side of the transversal, same side of the yellow line. So 3 and 5 are both in the interior, but on the same side of the yellow line. And then also 4 and 6. So those are your pairs, 3 and 5. And then also 4 and 6. Okay, only one pair left to do, and that's corresponding, which is my favorite one. Let's clear up some of this diagramming, and then we're going to talk about corresponding angles. So for corresponding, you have to look at the different intersections, right? The transversal is intersecting 2 different lines. When it intersects the first line, it creates an intersection of 4 angles. Let's make that stick out. So you see there's an intersection here that creates 4 angles. When the transversal hits the other line, it makes an entire new intersection with 4 angles there. Okay. For a pair of angles to be corresponding, they have to be in the same position for their intersection. Okay, so if we were to look at angle 1, so to speak, angle 1 is in the top left corner of that intersection, of that group of 4. What angle is in the top left corner in the other intersection? Well, that would be 5. See how they're in the same position? That's corresponding, okay? And you can do the same thing with the other 3. Same thing. See, angle 8 is in the bottom right. So that means it's corresponding with angle 4 because it's in the bottom right. They're in the same position. And you can do the same thing with 2 and 6 and 3 and 7. So there's always 4 pairs of corresponding angles. All the other pairs we talked about, alternate interior, alternate exterior, same side, all of those are, you get 2 pairs, but corresponding you get 4. So let's write down all of the corresponding angle pairs. We knew it was angle 1 and 7. I believe that I have that right. Yes. And then angle 2 and 8. angle 3 and 5. I'm sorry, I am not labeling these correctly. It was 1 and angle 5, what we have for corresponding. Let me fix that. 2 and 6. Okay. 3 and 7, 4 and 8. All right, guys, and that is your introduction to all of the angle pairs and all of the vocabulary in this first lesson for chapter 3 on lines and angles. Okay, please write down any questions that you may have. You can post those under the video or save them for class or put them as a message. Okay, I will see you guys in the next lesson. Bye.